Hello guys, so we are back again, and in this session we are going to continue with the higher order linear differential equation with constant coefficients. And in the previous session we had started the type 2, which was f of d into y equals to e to the power ax. Now in this session we are going to start with type 3 type 3 which is f of d into y equal to sine ax, right? So now in this lecture we will understand how to deal with this type. Our main aim will be to deal with this type. So this is the general format in which you will see the question, general form or general format, general form or general format. Now let's understand. You know how to find the complementary function. You know how to find the complementary function. Complementary function is the most easy to find. You need to get the auxiliary equation, get its root. Okay, check root's nature, and then use the format, okay, which was c1 e1 e to the power m1 x plus c2 e to the power m2 x and all that thing. So complementary function will be same for all, but here the only thing will change will be particular integral, which will be changed here. Like in the previous one, particular integral was the only thing that changed. Complementary function is same from the type 1, type 2, and here also complementary function is same only, right? You have to keep in mind that complementary function will be same. Now further on, now if you don't know why we are talking about this, because the solution, okay, general solution of a higher order linear differential equation is a combination of two things, which is complementary function plus particular integral. Complementary function is always same from type 1 we have seen, only this we have to find, which will be different. Let's understand how we are going to find its particular integral, its general format, okay, or pattern which we will follow to find the particular integral of this type. So, particular integral p dot I, you know, it's given by 1 by f of d into q of x. Here q of x is nothing but sine ax, or sine, they can also give you sine ax plus b. So you have to be prepared, there can be anything. Now what you have to do here in this type is replace each d square in f of d by minus a square. Keep in mind minus a square, it is very important. Many children do what, they write it minus a the whole square, which is completely wrong, and that's why they get the wrong answer. Remember, it is minus outside and a square, and also keep d as it is. In f of dy equal to e to the power ax, what we did, we directly substituted or replaced d by a. But here what we are going to do, we are going to replace only d square, which will be replaced by minus a square, and we are not going to touch the d. So that thing you have to keep in mind. Now let's understand the cases in which you will try to solve this problem. Now after substituting, there can be cases when you substitute d square by minus a square, there can be cases. Let's understand these cases and get deeper understanding of this topic. So let's discuss the case 1. In case 1, what we are going to see, when f of minus a square is not equal to 0. If what do you get by f of minus a square is not equal to 0? It is nothing but in d, wherever d square is present, you replace it minus a square, and after doing that, if you get this function not equal to 0, then what you are going to do, it is similar like in that f of a should be not equal to 0 in e to the power ax. Here also we are going to check the conditions of f of minus a square should not be equal to 0, which is 1 upon f of d. So 1 upon f of d square into sine ax plus b is 1 by minus a square into sine ax plus b, provided f of minus a square is not equal to 0. Now what we are telling, you can substitute here d square, replace it by minus a square, no doubt, but you will replace only when if f of minus a square after substituting should not be equal to 0. If it is equal to 0, this will become not defined. Now let's consider now there can be one more, which is nothing but that is understandable. Here d square is there, instead of sin x, cos ax plus b is there. Similar thing will happen, nothing great will change here, just cos will be there. So I hope you will understand this, provided f of minus a square is not equal to 0. Now let's move on ahead and see what we are getting after this. Now let's consider the case 2. Either it cannot be equal to 0 or it can be equal to 0, f of minus a square. If it is equal to 0, what we are going to do in that case? In that case, like in the e to the power ax type 2, what we did, we differentiated denominator and multiplied at the numerator by x. So here also we are going to do a similar thing. Here d square sine ax plus b is there. You know that after substituting, if I replace d square by minus a square, I am going to get f of d square equal to 0 or f of minus a square equal to 0. So what I am going to do, I am going to multiply at the top and differentiate at the bottom, and I will keep the sin ax plus b. What children do, they differentiate the sin x also. Don't do that. After this you can substitute and get your answer, which will be into sin ax plus b, provided f of f dash a square minus a square not equal to 0. Here same thing is happening. You can see here we are telling that f of minus a square should not be equal to 0. Same thing exactly. It can be true for cos also, right? Multiply the numerator by x and divide the denominator and keep the things as it is. Don't differentiate the cos ax plus b. You are going to get something like, now you can replace this and get your answer. Here it is dash, provided, okay, this condition is very crucial. Now what happened if f dash minus a square is equal to 0? We are going to differentiate it again, take the second derivative, you know, because after this thing was similar in the type 2 also. Now let's move ahead. If we move and take some problems, after this if it is also equal to 0, we are going to keep on taking the derivatives and get the answer. Now this thing was very much similar to the type 2. Now let's take the problems and increase our understanding of these types. Now let's take the problem. The first problem which we are going to take, in the first two problems we are going to discuss in detail with proper statements, and after that we are going to write only the important things which should be written, because the statements will be same for all. So you have become that much smart that I don't need to write the statement for you. Now let's solve this question. Just see, d square plus d minus 2 into y equal to sin x. Doesn't this seems like f of d into y equal to sin ax plus b or ax format? So one thing confirm, it is from type 3. Now this was just for your understanding. What you are going to write is auxiliary equation. Auxiliary equation is m square. Just replace d by m to get auxiliary equation in f of d, and then try to solve it. If you solve it, you will get this. You will get roots as, then you can say roots of are real and distinct. Now complementary function is very easy. It's not a big thing. You can easily found it. Which we will, after the two problems, we will write is CF directly. And here what we are going to do, roots are different. C1 e to the power m1x, which is minus 2x, C2 e to the power x. This is our complementary function. Particular integral will be what? 1 upon f of d, d square plus d minus 2 into sin x. Now here a is what? A is 1. In sin ax, a is 1. Just substitute d square by minus a square. Don't substitute d by a. It is not of type 2 that you substitute d by a. So when we substitute, or minus 1 square plus d minus 2 into sin ax. Sin x, here a is 1. You are going to get something like this will be minus, so you are going to get d minus 3 into sin x. Now what you will say, that sir, we are stuck because here d has appeared and you told that we don't need to substitute d by a. So how we will, now we will try to create d square. How we will create, just see. We will we will try to rationalize this by multiplying the numerator by d plus 3 and denominator by d plus 3. So we are going to get something like this. Agree? After this d plus 3, the whole upon d square minus 9 into sin x. After this d plus 3 into, here d square, instead of d square you can replace minus 1, minus 9 into sin x. After this what you are going to get? D plus 3 by minus 10 into sin x. So we are getting something like this. Now we are going to multiply this sin x with this, whatever here is present in the numerator. So let's multiply this sin x. So we are going to just keep this minus 1 by 10 outside. We are going to get d sin x plus 3 sin x. Now you know d is a differential operator. It will differentiate this. So we are going to get sin x, which will on differentiation will become cos x by 10, and plus 3 sin x. This will become minus by 10. So this is our required particular integral. Now let's write the general solution. General solution is equal to complementary function plus particular integral. After writing this, we can write the complementary function c1 e to the power minus 2x, c2 e to the power x, and after this we are going to write here the particular integral minus cos x by 10 and minus 3 sin x by 10. So this is your complete answer. In this way we are going to solve the next question also. Let's see the next question. The next question which we are going to get is this question number 2, which says d square plus 2d plus 5 into y equals to sine 3x. Now similarly here also you have analyzed it is of type 3. After doing the analysis that it is from type 3, you have to begin solving the problem. Now let's solve this. Here you can make out that auxiliary equation is nothing but m square plus 2m plus 5 equal to 0. Now you know m will be what? Complex. So you can get m value, which will be nothing but it will be something complex type, which will be m. If you calculate, you will get something -1 plus -2 iota. So we are getting 2. Now we can write roots of auxiliary equation are complex conjugate. After writing this, you will write your complementary function, which will be c1 e to the power what is the real part? -1 x c1 cos beta will be 2x plus c2 sin 2x. This is our required complementary function. Now we are going to look for particular integral. Particular integral denoted by pi will be 1 upon d square plus 2d plus 5 into sin 3x. What your job is to replace d square by minus a square, which will be -3 square. So here when you replace d square by -3 square plus 2d plus 5 into sin 3x. Now what many children do, they try to split this up. Okay, they try to split this up using sin 3x formula, which is not a good thing. Okay, you don't need to do that in this type of problem. When you solve it, after this you will get -9 plus 5 will be -4. So you are going to get something like 2d minus 4 into sin 3x. Let's take the 2 common outside. If we take the 2 common outside, we are left with d minus 2 into sin 3x. Now we are going to rationalize this. The moment I rationalize this, it will be d plus 2 the whole upon d square minus 2 square, which will be 4 into sin 3x. Now what we are going to do, we will do a simple thing. Here replace d by -3 square, which will get me 1 by 2 into d plus 2 the whole upon -3 square is 9, -9 minus 4 is -13 into sin 3x. So finally we are going to end up 13 into 2 is -1 by 26, keeping outside, and we will multiply this sin 3x with d plus 2 and try to get our answer into d sin 3x. We are going to multiply by d sin 3x, this thing, and here we will get 2 sin 3x. D is a differential operator, it will differentiate this, which will give us 1 by 26 here cos 3x into 3 plus 2 sin 3x as our answer. Now let's write the general solution. Now this was the previous problem, we are going to continue here only. So general solution is nothing but a combination of complementary function plus particular integral. Let's substitute the values and try to get our answer. This was complementary function, this was particular integral. Let's substitute this. E to the power minus x c1 cos 2x plus c2 sin 2x. Let's substitute this. 1 by 26 cos 3x into 3 plus 2 sin 3x bracket close. So this is our required general solution. Now hope you have understand each and everything. In the next session we are going to continue after this. Till then, practice these problems and see you in the next session. Okay, bye.